The following experiences all have something in common. You get up in the dark, and a visible shock is generated between your covers and pajamas. You're told to ground yourself before working with delicate electrical parts. You work with balloons, and they stick to certain things, like cloths and hair. You stick to the backside of invisible tape almost as well as the sticky side. You put on a polyester shirt after contacting it with other clothes, and it sticks to your body. What causes all these events are two phenomena called electrostatic energy and electrostatic force, as well as a few other guiding principles of electricity as we know it. Is it more shocking than it's made out to be? And are you positive you have all the foundation necessary for these topics? If not, click on the foundation edition of this video here. It's only a few minutes longer, and you'll understand these concepts even without a background in Physics 1 and Chemistry. If you'd like a challenge, or you're taking a course that requires the use of calculus in the concepts of electrostatics, check out the Isaac edition of this video, which will be available a few days after this release in the description below. Enjoy. Science. This is an electrometer. Everything is peculiar about it: its construction, its design, and its purpose. If you plan on doing everything in this video at home, go ahead and make yourself an electrometer. Don't worry, it's really easy. Start with a glass, plastic, or acrylic container. It doesn't have to be narrow at the top like this Erlenmeyer flask. Cut out two little tags of aluminum foil or tin foil and cut a section of metal wire. If the wire is coated with plastic, for example, skin the plastic off both ends as best you can. Feed the wire into a hole on the end of each tag and use a hole punch for a cleaner cut. Loop the wire around so that the tags can swivel at the bottom. If you have an Erlenmeyer, poke a hole in a cork and stick the wire through. Your setup should have the hook apparatus sealed on the inside of the container, and some of the wire should be on the outside. Take a metal object, preferably a sphere, and create a wire base so that there is a lot of contact. For containers like this, you can either cut a hole in the original lid for the cork or use tape like I did. If you do use tape, place a lighter object like a marble or a screw on top. Now you have an electrometer. Here's mine right here. The question still stands though. What can you do with this? Let's find out. Charge is a value that is easily described as the net amount of electrons in a material. Charges are measured in coulombs, and one electron represents 1.60 times 10 to the negative 19th coulombs. When I take this silk cloth and rub it on the balloon will steal some of the silk's electrons. The electrons are not flowing anywhere at the moment, so we call this static electricity. Particularly, this process is called charging by friction, where electrons are picked up by contact. In fact, all of the situations provided earlier are done through charging by friction. The balloon has a net positive amount of electrons, and the silk has a net negative amount of electrons. You'd be surprised to know, however, that the balloon actually has a net negative charge, and the silk has a net positive charge. A net positive amount of electrons result in a net negative charge. When one or more objects have a non-zero charge, they exert a force called electrostatic force on each other. It is represented by K, otherwise known as Coulomb's constant, times the product of the charges Q of two objects divided by the square of the distance between them, R. Regardless of their sign, they exert a force on each other, though the sign of the force may be different. In this situation, the cloth's charge is positive and the balloon's charge is negative, making the overall charge of the force negative. If both objects were positive, the force would be positive, and if they were both negative, all negatives would cancel and the force would also be positive. A positive electrostatic force is repelling, and a negative electrostatic force is attracting. Another way to prove that this balloon has charge is by using an electrometer. When something charged is brought up to an object, that object will go through an extremely fast process called polarization. Typically, the test object is neutrally charged to begin with, which means it has nearly the same amount of electrons as it does protons. When this balloon is brought up to an electrometer, the conductive ball sitting on top shifts many of its electrons to the bottom half and the bottom of the wire. Now, the top half of the electrometer has a positive charge and the bottom has a negative charge. This causes both tags at the bottom to become negatively charged, same negative sign, and repel each other. Notice that not just the negatively charged objects repelled each other, but some electrons repelled themselves. When you put the balloon on top, there were lots of concentrated electrons. Those electrons, of course, having the same sign and had an interaction with the electrons in the initial sphere, denoted by a positive electrostatic force, and repelled each other. Now, touch the balloon to the electrometer and move it away. Notice that the electrons from the balloon actually transferred to the electrometer. Now the apparatus is negatively charged and the tags stay indefinitely repelled. You can remove the net electrons from the electrometer by simply touching it, as most of those electrons are now in your body. If you take a glass rod and rub it with silk, the silk becomes negative this time and the glass rod is positive. This is simply a matter of the elements in the material and how they are oriented. The outer layer of silk contains low valence ions like potassium and calcium. If you want to know more about what's in silk, see the link in the description below. While glass contains mostly salts like silicon oxide that conduct electricity poorly and have a unique electromagnetic properties. Put the rod close to the electrometer and notice that it is also charged, but you cannot tell the sign of the charge. That is one flaw with the electrometer, so you'll have to take my word for it. One really neat way to utilize electrostatics is charging by induction. In layman's terms, this is the use of polarization to move electrons from a bountiful source. My body is a bountiful source of electrons, so I'm going to make contact with the electrometer, which is electrically isolated or insulated from the table or anything else. By moving the charged balloon close to this ball, it has polarized the ball, but because the electrons have been forced to the same side as my finger, the balloon has essentially moved a mass amount of electrons out of the ball. I will remove my finger and then move the ball far away. This therefore gives the electrometer a positive charge and causes the tags to repel. Another way to charge by induction is taking two metal balls in contact but insulated from the surface and again introducing a charged object. The balloon causes most of the electrons in transit to move to the ball on one side of the balloon. While the balloon is still in contact, move the spheres away from each other. Now, each balloon has a charge that is opposite in sign, and no new electrons were transferred to or from the system of balls during the process. Please subscribe. I'm not out to fill your recommended with clickbait. This is just my journey to college. This is Alistair. Have a blessed day, and see you next time on Layman Digest.